Okay, question 4 is about table operations. So we have here a table with a bunch of trees and some data about them. We have the year they were planted, the density of the wood, whether or not it was in a fire, the type of tree, and the height it grew to. So part A is asking the number of trees that were ever burned in a fire. So to get whether or not they were burned, we want to look at this column, burned, right here. And since that's a yes or no type thing, the function we want to use is np.countNonZero. Oops. Because that can take an array of true and false values and return the number of values that are true. So then we want to get the burned column right here. So to get that, we just have to add column, trees.column of burned, which will give us our desired column. Okay, and note that burned is the values are the string yes and no. They aren't the Boolean values true and false, meaning that we need to set it equal to yes to get the true and false values. Okay. Part B is the height of the tallest tree. So to get the tallest tree, we want to use the function np.max, or just max. And then since we're getting the height, we want the column that corresponds to the height, which is just called height. So trees.column of height. And that will give us the height of the tallest tree. Okay. Part C is the type of tree of the least dense tree. So the code gives us two lines here. The first is sorted equals trees of blank dot blank, or trees dot blank of blank. Then we apply some function on the sorted table. So the fact that this table is called sorted tells us that we want to use the sort function. And since we're looking at the least dense tree, we want to sort by wood density. Then we can sort either by descending equals true or descending equals false. If we want the type of the lowest density tree, we want to note that in the second line, it wants the element at index 0, meaning the first thing in the table. So we want the least dense thing to be at the top. And to do that, we want descending equals false, because we want to go in increasing order. Okay, so then sorted dot blank of blank dot item 0. So when we're getting this item 0 thing, that corresponds to an array. And so these two blanks here, we want to fill in how to get an array. And what do we want to get? We want to get the type of tree. So we want to do column, and we want to get the type. And taking item 0 of there would give us the type of the least dense tree. Okay. Part D is we want to only get the rows for burnt trees and then get rid of the burned column. So the first thing that the code gives us is this drop here, and drop gets rid of columns, and so we want to get rid of the burned column. So let's just do that right here. Okay, so now we only want the rows for burnt trees. So remember, to select certain rows out of a table, the best function to use is where. So now we want to use a predicate function. So then, since we're only getting the burnt trees, we want to take values out of the burned column. And then, so if the tree got burnt, then the burned column would be equal to yes. So we can either do yes, or we could do r dot equal to yes. They both work the exact same way, and you get points for both. Okay, part E. So we want a new column called growth speed that takes the average growth in meters per year. So basically we take how long has this tree been around, and then how tall is it. And if we divide those two, we can get on average how tall did the tree grow each year. Okay, so the first line is speeds equals trees dot something of something divided by 2019 minus trees dot blank of blank. So the first thing we can fill in here is the second part of the line. Um, this example gives us a nice example of what to use. So to get the age of the tree, we do 2019, which is the year at that time, minus 1999. And so we have the 2019 here. What we should do is make the second part of this the year that the tree was planted. And that would be trees.column of year. And that's the year the tree was planted. As for the first part, we want to get the height of the tree. So we can just do trees.column of height. And remember that arrays, they do operations by each element, meaning that speeds is going to give us a new array with each individual tree's average growth rate, and it'll be in order properly. So now the second line is trees.blank of growth speed, comma blank. So we want to add in a new column called growth speed, and to add in new columns, we should use the function withColumn. And withColumn takes in two arguments, a growth or the name of the column, that's growth speed, then the array that we use to feed it in. So that's going to be speeds. Okay, part F is going to be basically the same problem, but we're going to do it in a different way. So in this way, we're going to define a function called compute speed, and then use that to add in a new column. So let's first define compute speed. And so compute speed should take in two arguments. It should take in the height, which is how tall the tree is now, and then the year, which is what year the tree was planted. And the way we calculated it before is we take the height, and then we divide it by 2019 minus the year to get the age. Okay, so we should return height divided by, in parentheses, 2019 minus the year it was planted. And this will work for any combination of height and year that we feed in. So now we have trees.blank of compute speed, comma blank. And the function we're going to use here is going to be apply, because we want to get the we want to apply this function compute speed to every single tree in the trees table. And so after the compute speed here, the rest of the arguments we want are what we feed into the compute speed function, and that's going to be the column height. And remember, we're just feeding in the labels and then the year of planting. And now all we have to do is add this column back into the table. So the same way we did before, with column, growth speed, comma, speeds. Part G. We want a new table called type heights, which has one row per type. And then we want the name of the type and then the average height of trees for that type. So this first line is called trees to call, and that means two columns. So let's just get this column or this trees table into two columns. So to select certain columns, we use the select function. And the columns we want are type and height. That's our first line. Then type heights equals trees.toCall. And then what do we want to do with this table? we want to have the name of the type and then the average height of trees of that type. And the table function we use for that is group. So we're going to group by the tree's type, and then once we get those values, what do we want to do then? We want to take the average. So we want to do np.mean, and then calling type heights would just give us the table. Okay, part H. So now we want to add in a new column called percent of average height. So we want the tree's percent of average type, or average height for that type. So basically it's saying like how much bigger or smaller is this tree than the average tree of that type. So the big hint it gives here is that we should be using the type heights table in order to get an average. So the first thing we need to do, if we're going to be using type heights, is to integrate the table's trees and type heights. So the best function we have for that is join. And so join takes in the arguments, the column that they both have, and that's going to be type, and the other function that or the other table that we're joining it with is type heights. So now we have a table that's everything in trees, but then for each, there's a new column in trees that has the average height of those trees. Okay, so now trees.with column, percent of average height, and then it's 100 times, remember that we use the 100 for to multiply by when we're using percentages, and then 100 times with h dot blank divided by with h dot blank. So let's go back to our example here. We have 23 minus 20, or 23 divided by 20. If the average is 20, and then our tree is 23. So in the numerator, we want the height of our tree, and then in the denominator, we want the average height. So in the first here, we do with column, or with h dot column of height divided by the average. So that's going to be with h dot column of, and this column is going to be called height mean. And the reason why is because in part G, where we did type heights, we fed in the function np.mean, and what that does when we use group is it adds the function name to the end of our column name. So instead of having height, it would be called height mean. So that's where we get this height mean from.